Welcome to the Brim Sneak Peek. My name is Phil Zhevsky. We're excited to show off our new open source tool that will help you quickly find the interesting packets in your network traffic and a whole lot more. We'll briefly touch on the problem we're solving, then dive right in and show you a demo of Brim. Then we'll share some details of what's inside Brim that help make it so powerful. Finally, we'll close out by letting you know how you can get your hands on the software and get involved with the community. Let's get to it. There's a common problem I think many IT professionals can relate to. We all know packet captures provide vital information for network troubleshooting and security, but we also know they can get big. Most of you have probably had an experience like this one. We've clicked to open a PCAP file in Wireshark, and based on the crawling progress bar, we know we're going to be waiting a while. We were patient, so Wireshark eventually finished loading. Obviously, there's too many packets here to look at all at once, but we know the interesting packets we want to see are in there, so we apply a filter. We found our packets, but if we need to do more searches, this is going to get old fast. As we were told recently by one Wireshark power user, I spend most of my time waiting for Wireshark answers. Of course, your experience will vary based on the size of the PCAP file, but in general, we're unsurprised to find that the load times get substantially longer as files get big, and particularly as they exceed the amount of memory on our workstation. If you're really unlucky, you may come across a packet capture so challenging that Wireshark won't even successfully open it. Fortunately, now we have Brim. Brim is an open source desktop tool that allows you to search your network traffic and quickly find interesting packets and a whole lot more. Let me show you how Brim handles our big troublesome PCAP, then I'll tell you more about how it's done. We'll launch Brim and drag and drop the PCAP file into the app. Brim immediately starts a one-time pass through the packet capture to generate two powerful sets of data to go with your packets. Rich summary logs about every flow, including app-level analysis, and a packet index that will help the Brim app quickly open up interesting flows in Wireshark. The application allows us to start querying the summary logs as soon as the first ones are generated. But let's give it some time to finish processing to the end of the full PCAP file. Now with all our data summarized in Brim, let's start searching it. If we enter the same hostname we just filtered for in Wireshark, Brim quickly responds to tell us there's DNS information as well as hits for other traffic like SMTP and HTTP that involve the same hostname. Once we double-click on the DNS event, Brim shows us a top-down view of all the summary details for the app-level DNS exchange. A visualization leads us to the underlying connection record for the entire UDP flow, and with one click, we can see connection details and a PCAP button. With a single click, Brim's fast packet index pulls up the same packets that we just waited for earlier in Wireshark, now in the blink of an eye. Clicking on this SMTP event, we see it's just as easy to see packets from any of these other flows. With just a couple clicks, you can be looking at the byte stream in Wireshark. So how does it work? Let's start by talking about the summary logs we just saw. These are actually generated by Zeke, formerly known as Bro, another open source tool that's packaged alongside the Brim application. If you're not familiar with Zeke, it's a tool that reduces incoming packet streams into higher level events. Whereas packet captures are great for when you need to see every byte, we know they're huge to store, transport, and open. And while NetFlow records summarize data to a much smaller form factor than PCAPs, there's just not enough detail there to tell you much about what's really going on in your traffic. Zeke is like the Goldilocks of summarizing network traffic, way smaller than PCAPs, but still with plenty of detail. In this way, you can think of it as being like a rich index into your packet data. Zeke was originally written by Vern Paxson at Lawrence Berkeley National Labs in the mid-90s. Its origin story actually intersects with Brim's. In the 90s, Vern was sharing an office with Steve McCann, who is now the founder of Brim. Steve had popularized PCAP through his writing of libpcap and co-authoring of TCP dump. Meanwhile, Vern had an idea for a network monitoring system that leveraged packet data, and that idea ultimately became Zeke. As shown in this diagram from Vern's original research paper, the Zeke system leveraged libpcap to get access to flow data. While TCP-dump and PCAP made the way for other general network visibility and troubleshooting tools like Wireshark, Zeke has since become embraced largely for network security use cases. But as we've already started to see, the events produced by Zeke give us lots of rich detail about our traffic, even if security is not our primary focus. Here's a quick look at the kind of details that appear in Zeke Logs. At the base level, we have connection events. One of these is generated for every IP flow that's observed. For example, there's info here like the 4-tuple IP and port combo, just like we see in NetFlow records. But Zeke goes much further by performing application protocol analysis on every byte stream, creating rich summaries that can tell you key characteristics of the app-level traffic without requiring you to dive every time all the way down to the packet layer. Zeke can also be extended and customized, as it comes with its own powerful scripting language and plugin architecture that can be used to add or modify additional fields to events or create analyzers for entirely new protocols and new event logs to go with them. The schema of Zeke Logs also reflects the interconnected nature of your network traffic. For instance, a unique identifier, or UID, field appears in most Zeke Logs, which is what joined the DNS and SMTP events we looked at earlier with their underlying connection records. The 5-tuple information from the connection record, along with the timestamp for the connection start and its duration, gives Brim the information it needs to use its packet index to quickly pull the packets from your large PCAP to be opened quickly in Wireshark. Now that we know a bit about Zeke, let's tour the Brim application a bit more to understand everything we can do with this rich data. Going back to our initial view, we see that Brim looks similar to other log search tools. There's a search bar for entering queries. Brim uses a pipeline query language that should be intuitive for those accustomed to working with Linux shells like Bash. The most recent events are displayed below, along with a histogram showing event counts over time. If we hover over a bar, we see one of the first ways that Brim highlights the uniqueness of Zeke data. The colored tiles show the different Zeke log types. Pickers are available for specifying the time range, and the histogram can be brushed to zoom in. A picker is also available for quickly accessing the data associated with different PCAPs, and just like a browser, you can also open a separate tab to load new PCAPs or call up the data from previously loaded ones. Let's start a new search. If I enter an IP address, as you might expect, Brim filters all the Zeke events to show only those involving that IP. If we want to see only DNS events related to that IP, now we have a Boolean AND of our two search terms. However, the Brim application has clickable features that make it easy to construct searches even if you're new to the query language. Let's go back to our base IP search. Let's say we want to use this IP as the basis for a lot of searches we'll be performing. Clicking this thumbtack icon, we pin what we've typed, and it now becomes a base on which we can add more search terms. As an alternative to typing queries directly, if I right-click on a field such as this HTTP path tile, I can select the filter option, and the syntactically correct search term is appended for me. I may want to pin that as well, and now when I drill down more into my HTTP, such as by looking for methods like get, options, or post, we're seeing the events that match a Boolean AND of all three search terms. Now let's open up the search history on my left panel, and we see something that's been cooking in the background since we started. Here we have a time-ordered record of each query we've performed in the application. With a single click, any of them can be retrieved and re-executed. The tree view also gives a history that's organized based on the language structure with hierarchy created by the pinned search terms. So if I recall this previous query and change the base IP address, we can see that a new branch of our tree is automatically created. The data types are rich and network-centric, such that we can use CIDR notation to query by subnet as well. Let's recall an earlier search and see more ways the Brim app helps us build queries. If we want to do some simple analytics, right-clicking on a column shows us an option to count by this field. Now the query has been appended to give us a table of event counts by responding port. If we want to sort it, just click on the column header and the pipeline is appended with the correct syntax to forward them forward or reverse order. Once you've got a table like this, it's also easy to drill down further. In fact, this table shows us another powerful characteristic of Zeke Logs. Zeke's protocol analyzers use signatures which watch for typical protocol dialogues on all flows, allowing app protocol traffic to be identified independent of server port. As we see here in the counts table, in addition to the common ports like 80 and 8080, Zeke found HTTP traffic on all these non-standard ports. Right-clicking on a row in Brim, we can select the Pivot to Logs option, and our query is rewritten to isolate just those events. As before, we can double-click any event to see the rest of the app protocol summary that Zeke analyzers generated for us, and click immediately to the underlying connection record, and open it up in Wireshark. Now we can see the packet level detail. Checking the byte stream, we can see that it was indeed HTTP traffic all along. Once you've done some work in the application, you may get to a golden query that you want to run elsewhere, such as in your scripts or automation. Brim facilitates this using a copy for CQ option. This leads us to another component of the Brim solution that's available as open source technology, a command line log processor called ZQ. Much like how Tshark and TCP dump provide a command line alternative to the Wireshark UI experience, ZQ includes the same execution engine and query language we just used in the Brim application, now from the command line. Running the command that was provided by the Brim application, we can see the same table of results we just saw in the app. Here's a look at Brim's GitHub repository for ZQ, where you can go to learn more about ZQ and read the query language documentation. The query language in ZQ is exactly the same as the one we've been using in the Brim desktop application. While we're outside the app, let's also take a closer look at the data Brim created for us when we loaded our PCAP. Next to the location of the original PCAP on our file system is a .brim directory. In here we can see a .bazing file. Bazing is an efficient binary format for storing Zeke logs that's used by ZQ and the Brim application. You can find more details on Bazing and other log formats supported by ZQ in the documentation linked from the ZQ repository on GitHub we showed earlier. In this case, we can see the Bazing file is about 28 times smaller than the original PCAP, which goes a long way to explaining why queries in the Brim app execute so much faster than making a full pass through the PCAP in Wireshark every time. Here we can also see the packet index that Brim created when we loaded the PCAP. This is the index that Brim accesses based on the 5-tuple timestamp and connection duration information from the Zeke connection log in order to quickly pull up packets from within the large PCAP instantly in Wireshark. Back in the Brim application again, let's look closer at some of the features we touched on briefly before. We once again start with a search for a hostname, and we've narrowed down to just a handful of events. Double-clicking on an event, we once again open the right side log detail panel, which saves us from having to scroll left and right to see the many Zeke fields. To help you become familiar, Brim provides detail about every Zeke field when you hover your mouse over the field name. We once again see the correlation of events associated with the same connection, which we now know is thanks to the UID field that's provided in the Zeke data. Clicking to the underlying connection record, we see another handy Zeke-centric visualization. Zeke's history field encodes the life cycle of a connection, but since only experts may be able to decode this shorthand in their heads, Brim turns it into a sequence diagram. Another visualization appears if we click a file event. Zeke can give us a hash of every file payload observed in app protocol exchanges. Once we click a file event like this, Brim automatically kicks off a query to summarize where we've seen this hash appear in other file events. Now we can see that this file payload appeared 3 times in our PCAP, each time from a different host, and under different GIF file names, even though Zeke flagged them as executables. Suspicious. Right-click also exists to quickly launch a check of this hash in VirusTotal in our browser, or check an IP in Whois. We've now seen evidence that a receiving host has been downloading DOS executables hidden behind GIF file names, so we're probably looking at a security incident. Therefore, we might next want to look for signs of DNS exfiltration. A right-click gives us a quick way to start a new search based on this IP address. Let's narrow the search to include just DNS queries and sort it with the heavy hitters on top. In the table, we can see harmless stuff like Facebook, but not too far below are escaped hex codes and garbled Unicode indicating this host has been sending DNS queries with binary data in them, as well as suspicious host names like this one. After a pivot, we can use the waterfall visualization to click through the queries that happened over this DNS flow and see how it started innocently enough, then soon binary data was being smuggled out. As always, if we want to jump to looking at the packet level, they're just a click away. For the traffic we've examined, we've had the luxury of being able to see all the bytes in clear text and parse them into fields based on their app protocols. You therefore might be wondering what's to be done if your captures contain encrypted traffic, as is increasingly the case. Here we see the power of how Zeke can be customized and extended. 2 example projects, JA3 and HASSH, have been shared with the Zeke community by Salesforce, and these create fingerprints on SSL and SSH traffic respectively, and help you make important conclusions about your encrypted traffic based on these fingerprints. There's more detail on this subject than we could possibly get into here, so check out the GitHub repositories and the YouTube video linked below for more information. There's also lots of interesting research being done around encrypted traffic by Corelight, which is a vendor that provides commercial Zeke offerings for the enterprise. Check out their blog posts linked from here to learn more. We'll wrap up by showing you one more type of log produced by Zeke that's fun to explore in Brim. The events in the weird log are created when the protocol analyzers encounter malformed or unexpected traffic as they're parsing it. These might be signs of malicious activity, or it might be indications of malfunctioning or misconfigured hardware in the network, or maybe it's a false positive just because your traffic looks a little different than what's typical. We won't get into all the details of the hundreds of anomalies that Zeke can flag this way, but here's a peek at some of the more than 200 types of weird events you might see. There's a great video online where you can learn more about Zeke's weird events. Going back into Brim and checking out weird event data, we can see several such events are triggered. Let's count them up by named category and sort them. Let's see what a SYN after close looks like. Once again, using Brim's Pivot to Logs option, we can quickly get to the packet level and see there's a FIN and a SYN that comes right after. Maybe we want to go check out that host or look for routing problems in the network. Likewise, at the app layer, let's see what a missing HTTP URI looks like. Sure enough, the proof is once again right there in the packets. That's our quick tour of what's possible with Brim. Just to recap, if you're a Wireshark user, you've seen how much easier Brim will make it for you to understand what's in your PCAP and get to the packets fast when you need them. Once the Brim app has performed its one-time pass through your PCAP to turn it into Zeke data, now you can do lots of operations like the DNS filtering example we showed earlier in seconds, rather than enduring long waits in Wireshark every time. For the mathematically inclined in the audience, here's that same chart with a logarithmic scale. As you saw, Brim's query language for doing those operations is as easy to use as a search engine where you can just type a host name or IP address and quickly see all relevant activity, yet it's powerful enough to construct sophisticated filters and pipelines. And that power is there for users who already know Zeke or are experiencing Zeke for the first time through Brim. Just click through the app to learn about Zeke fields, build queries, pivot, and call out to other tools. Fast access to your packets are always just a click away. Want to get started? Come to the Brim Security website where you'll find links to download the software. Links to our GitHub repositories are also shown here where you can find code and documentation. And if you have questions or want to get involved, come find us on our community Slack workspace. There's links to join at the bottom of the READMEs in our GitHub repositories.